Hello viewer, welcome to Samuel Academy. My name is Samuel. In this video, I want to talk about the reactivity series in chemistry. The reactivity series is a chart that shows metals in order of decreasing reactivity. For example, in this chart, we have the following metals: potassium, sodium, lithium, calcium, magnesium, aluminium, zinc, iron, lead, copper, and gold. Carbon and hydrogen are given just for comparison. So the metals which are high up in the series are more reactive than those which are below. Okay, so it is a chart that shows metals in order of decreasing reactivity. As you go down in the series, the reactivity decreases. Okay, a metal that is more reactive, its reactions are more vigorous. For example, sodium is more reactive, even potassium, lithium, and so on. So you find that, like in this case, these metals react with water, and like in the case of sodium, the reaction is very violent, is vigorous. If we put a piece of sodium over cold water, you'll experience a very violent reaction. Okay, so that's what we are saying here, that a metal that is more reactive, its reactions are more vigorous. We can see like copper and gold, there's no reaction between them and water. Now, such a metal that's more reactive, it loses electrons more easily in reactions to form cations. So a metal like sodium readily loses its electrons in a reaction to form cations. Like in this case, sodium ion. A cation is a positively charged ion, and a negatively charged ion is called an ion. So these are cations. You can see potassium ion, sodium ion, lithium ion, like that. These are cations. So a metal that is more reactive, it loses electrons more easily in reactions to form cations. A metal that is higher on the reactivity series has the ability to displace a metal that is placed lower from that salt solution. For example, if we have magnesium solid, magnesium metal, and you react with the copper sulfate solution, which is a salt of copper, the magnesium will displace copper from that solution to form magnesium sulfate and copper solid. So I'm saying that a metal that is higher on the reactivity series has the ability to displace a metal that is placed lower from the salt solution. So in this case, we can see that magnesium is higher up than the copper. So it is able to displace the copper from that solution. A metal which ranks higher on the reactivity series requires greater amounts of energy to isolate it from its ore and other compounds. For example, in metal extraction from the ores, you require more energy, more amounts of energy to isolate such a metal from its ore if it is higher up on the reactivity series. Metals above hydrogen in the series can displace hydrogen from acids such as hydrochloric acid and sulfuric acid. So this is hydrogen, okay? So those metals which are above hydrogen in this series can displace hydrogen from acids such as hydrochloric acid and sulfuric acid. For example, a metal like magnesium, alright, which is here, which is above hydrogen, can react with a dilute nitric acid to form magnesium nitrate and hydrogen gas. So it is able to displace hydrogen from the acid, okay? And metals which are below hydrogen on the reactivity series do not react with dilute acids. For example, these metals which are below hydrogen, like copper and gold, they don't react with dilute acids. Although gold is able to react only with strong oxidizing agents, all right? So the reactivity series is very important in chemistry, and I'm sure you have got some point in that video concerning reactivity series. So I want to request you to subscribe to Samuel Academy in order to be able to view more videos in chemistry, mathematics, physics, geography, and weather. And leave a comment. Thank you.